Hi, this is the last page of the volume of revolution notes. It's going to be kind of like in the style of what an old AP FRQ used to look like, where it was find different areas. So kind of like the first part of when we learned about top minus bottom, so it's like two-dimensional stuff. And then the last part would be taking you to some third dimension using cross sections, or in this case, a volume of revolution. So before we start, let's just make sure we understand kind of what we're working with. We have a function, this guy right here, tangent, okay, tangent x, right? So we have this guy right here, tangent x. And then we have another function, uh, y equals 2 minus x. So this guy right there. All right. So kind of let's get started with this. Couple of things you want to do. You want to find potentially points of intersection where this stuff crosses. So for example, this guy right here is y equals 2 minus x cubed. This would be when does it equal 0? So 0 equals 2 minus x cubed. X cubed equals 2. X is going to be the cube root of 2, or 2 to the 1/3 power. Now for this one, where does 2 minus x cubed equals tangent x? We got to go to our calculator. Okay, so we're going to go to our calculator. We're going to figure out, we're going to go to y equals. You're going to go tangent x for the first one. Go down. 2 minus x to the 3rd power. Okay, and let's hopefully if we graph this, this is what we would get. There's tangent. And then there's our shape. So this is kind of where we want to go. So we're going to zoom in a little bit. So zoom in, enter, and get closer to where we really want. Okay, how do we find the points of intersection? You guys remember it's going to be second calc. So second calc. Intersect is 5. So 1, 2, 3, 4, 5. So then we hit enter for the intersect. We want to move our little blinking thing over to where it's intersecting. Now remember, you can have more than 2 graphs here. So, oops, a little too far. Okay, and what you're going to see if you just hit enter, pick the second graph, you can move up and down to change between the graphs. So in this case, we're just going to keep it with 1, and then you hit enter. It's going to give us our points of intersection. Okay, so we're going to write those down now. In this particular case, it's going to be 0.90215505. 90215505, comma 1.265757, I think. But this one, the y value, we won't really need too much. We do all these decimals because we want all of the error to be here, not in the first 3 decimal places. All right, so find the area of R. We've done enough setup work. We should be able to kind of do this part pretty quick now. So we're going to go A equals. So for part A, find the area of R. Well, you're going to notice that it's going to have like 2 different regions because you have 2 different types up here, 2 different tops. So this guy is tangent x. This side over here is 2 minus x cubed. And then this bottom part is y equals 0, which is the x-axis. All right, so we need two integrals, right? Because we have two different sections right here. So the first section is going to go from 0 to 0.90215505. Top minus bottom. We're not doing anything squared. There's no numbers in front because we're not finding volume. So this will be tangent x minus 0 dx plus the integral from 0.90215505 all the way to 2 to the 1/3 power, and it's going to be top minus bottom, so in this case 2 minus x cubed minus 0, the x-axis, dx. So whatever that answer is will be your area. Okay, part 2, find the area of S. Okay, so the area of S is slightly different. Okay, so for part B, the area of S will be something like that. This part right here will be y equals 2 minus x cubed. Okay, notice how this one's on top now. This right here was tangent x, and we're trying to find this area. So we're actually doing top minus bottom. There's no x-axis in this one. Okay, we know where this one will, what point this is. So this point right here is 0.90215505, comma 2657507. Okay, so we're just looking at this part right here. So we're going to go from 0 all the way to this x value. So 0 to 0.90215505. Top minus bottom. So make sure to always use parentheses because you never know when you might have to distribute a negative. Okay, so if this had more than one thing in it, the negative would have to distribute all the way into that. Okay, so top minus bottom, there's your area. Okay, pretty straightforward. All right, now to find where this, if we revolve this area around S, so you would get something like, so there's your area right there. You would get another similar kind of shape like that, okay? And then it would revolve. So you would get kind of like a washer-like situation because there'd be this empty space here, and then there would be this bigger circle here. So it'd be a washer kind of situation. So let me erase all this. So how do we do this then? Well, we know there's going to be a washer, so this part right here, we're going to rotate around the x-axis. So this right here will be little r. This right here, okay, will be big R. And if you recall, this right here is y equals 2 minus x cubed. This function right here, tangent x. Okay, so to set up our integral then, our integral will be, remember it's pi r squared all the time, so this would be from 0 to 0.90215505. Top minus the axis of rotation. So pi radius squared, so this will be 2 minus x cubed minus the axis of rotation. Okay, you remember the x-axis is y equals 0. Okay, so that's why this is 0 right there. And this would be dx. So that is the that would be the whole volume If we rotate it around, completely filled in. So now we subtract out the empty space, okay, which is represented by this little r. So this little empty space right here, okay, we're going to subtract out that r. So similar kind of bounds from 0 to 0.90215505. Pi radius squared. So this will be from tangent x all the way down to the axis of rotation. So this will be tangent x minus 0 squared. Again, don't forget the squared like I did over there. Crap. So make sure to put a little squared there. This is pi r squared. So good thing I caught that before I hit end. Okay. All right. So there you go. So you have the big radius, pi big radius squared minus pi little r squared. Okay? Now, could you have combined all of this into one nice single integral? Sure. You could have done something like this. 0.90215505. In case you see this in a multiple choice, they might try to trick you by combining everything. So this would be this. 2 minus x cubed. Okay, sometimes they'll just write it like that. Squared, because the 0 doesn't matter, minus tangent x squared dx. In other words, they'll make it look like this. Pi big R squared minus pi little r squared. Okay? And just remember, it's never, okay, it's never big R minus little r squared. It's never like that. You always square the radiuses separately and then subtract. All right, so that's it for the notes. Hopefully that helped. Send me your questions if you need it. Okay? All right, bye.